So we are going to start off with terrestrial navigation or chart work in this presentation. Now, before we begin the actual chart work, uh, let's go through some basic general instructions. Now, what I have tried in these presentations is that I'm picking up the chart work topics right from the basics. The intention is that one, there should not be any doubt left in your mind. And secondly, even if you have forgotten the chart work which you did during the previous grades, so it should not cause any difficulties to you. So we are starting right from scratch, right from the basic, so much so that even if a pre-C candidate goes through the presentation, he should be able to easily pick up and understand these chart work procedures. So I'm not leaving anything to chance, starting from the basics. Now, these general instructions are important because many a times when you appear in MMD papers, sometimes you feel that you have done your paper well, but even then the marks which you are getting or the result which you get is not up to your expectations. Now that could happen because of not following these small things which may lead to reduction in marks. So let us go through these general instructions first. Now when you start your chart work, you see the charts which are there in the MMD, they are used by the candidates batch after batch. So you may have some old lines or markings on the chart. Uh, you should erase, first of all, before starting any work on the chart, you should check if there are any lines or markings, and you should erase all these lines and markings. Because once you have made your plots, these unnecessary lines or markings could make your plot confusing and difficult for the examiner to understand. So erase all the old lines from the chart before starting the work, including all markings. There may be markings along the latitude and longitude scales. There may be markings along the compass roses. So erase everything. We use a 2B pencil for chart work that gives us the required darkness, as well as it is soft, so it does not damage the chart. Use good quality tools. Use a good quality eraser. The tools which you are using, which could be parallel rulers or set squares, sliding rollers, any other tool which you are using, prefer or recommended to use transparent tools. The transparent tools allow you to see what is behind the parallel ruler or sliding ruler or set square. It does not hide any markings. So opaque tools obscure the information, and it may be a difference between doing a question right or wrong. And during a MMD paper, time is of paramount importance. So if you are not able to see clearly the information on the chart because of the opaque tools, that may lead to some errors creeping in your calculations. Now, to increase the accuracy of your plots, we can follow some of these instructions. It is recommended to measure all the bearings and courses by using the nearest compass rose. Avoid using the angle markings on the parallel ruler. Though these angle markings are provided, they are given there, But as far as accuracy is concerned, the accuracy of these angle markings is much, much lesser. So at least for exam purpose, we should rely on using the compass rose, not these markings on the parallel ruler or set squares. Even when you are transferring the courses or bearing lines from the compass rose, or you are drawing parallel lines, if it is possible, prefer using the same edge of the parallel ruler, because using different edge also could bring in some amount of error in your plots. Now, when you are plotting a certain point on the chart, or you are measuring the latitude and longitude of a certain position, it is always better to use the nearest parallel of latitude and the nearest meridian, or if you are measuring a course or a bearing, it is recommended to use the compass rose with the help of the parallel ruler. Avoid using a compass or divider for these purposes.
Beta, all okay up to here? Some basic stuff?
Yes, sir.
सर सेम एज का मतलब सेम साइड ना सर, जिस पैरेलल आपने बोला?
Yeah, that's right, beta. It gives you a little more accuracy. Same edge or same side of the parallel, whatever edge you are using, transferring all the lines using that same edge gives you a little more accuracy. If you shift the change the sides, then you see there is always a play in the parallel ruler, and that play may be different on both the sides. Okay, that's the whole intention. Okay, let's move ahead.
For measuring up the latitude and longitudes, there is a tendency that if the compass and divider is too tight or too loose, so by the time you transfer it from the position to the latitude or longitude scale, the compass or divider may get disturbed and it may give you a wrong reading. Now, another very important thing for chart work is the use of proper symbols. Now, this is very, very important, because when we make a plot on the chart, we are trying to communicate with the paper checker of what we have drawn on the chart. Usually the plot is not labeled. We do not write there that this is my course made good, this is my course steered, or this is the current. What we do is we use the symbols to denote all these quantities. So use of proper symbols is very, very important. So use appropriate symbols to indicate various parameters like the course steered, or CTS, which is course to steer, CMG, that is course made good, current, celestial position lines, transferred position lines, DR positions, estimated positions, and fixes. So let us see these symbols one by one now. So you can see the symbols on the right side of the screen. Let's go through these symbols one by one. So on top here, you see the symbols we used to mark a dead reckoning position or DR position. So that's a simple cross using a horizontal line and a vertical line along with the time mentioned. So this is the symbol we use for marking or plotting a dead reckoning position or dr position. The next symbol which you see is the symbol for a estimated position, in short also known as EP, Eco Papa. So we mark off a triangle with a dot in it, and the time is also mentioned here. So this is the symbol used for EP, estimated position. The third symbol which we see here is the symbol used to plot a fix. So we have a circle with a dot in the center representing the position, and you have the time mentioned here for which this position was applicable. So this is the symbol for a fix or a known position. Now, if you want to mark the fix obtained from an electronic device, say for example GPS or GLONASS, then it is represented by marking of a square with a dot in the middle, along with the time for which this fix or position was applicable. Then the next symbol which you see is the symbol used for the course steered. So whatever course the vessel has steered, we denote that by marking of a single arrow. So you see this single arrow. Along with the single arrow, we also mention what is the course which the ship is steering. So you see here in this particular case, 095 degrees true. That's the course steered. The next symbol which we see here is the symbol for course made good. So to represent the course made good, we denote it by double arrows. So you see double arrows marked on the course. That denotes it is the course made good. Along with it, we also mention what is the value of the course made good. The next symbol which we see here is the symbol for current. Current is represented or marked using 3 arrows. So you see 3 arrows marked on the current vector. Along with it, we mention what is the set of the current or what is the direction in which it is taking us. These 3 are very, very important in chart work. Almost 90% of the chart work questions, they involve the concept of course, speed and current vector triangle. And all these 3 symbols are very frequently used there. That is the course steered, the course made good, as well as the current. Now the next symbol which we see is the symbol for marking a position line. So a position line could be a bearing from a particular object, say for example a lighthouse, or it could be a celestial position line. So it is marked by putting an arrow at the end of the line. If it is a bearing, the arrow will be only on one edge or one side of the line. But if it is a celestial position line, in that case, you will have the arrows on both the sides of the line. Now this arrow at the end of a position line or PL indicates or denotes that it is not necessary that the vessel's position will lie on this line segment only. The vessel's position can be anywhere on the line extended on the side of the arrow. So this arrow represents the vessel's position could be anywhere when we extend the line in this particular direction. Now the next symbol which we see here is a transferred position line. What is a transferred PL? Now, many a times we need to transfer our position lines from one time to another time. Let's say a PL was taken at morning 9 o'clock and we need to transfer it to 10 o'clock. So when we transfer APL, it is represented by marking of double arrows on both the ends of the position line. So these double arrows indicate that this PL was not taken at this time. It was taken at a different time, but it has been transferred here for our use. So this is the symbol for a transferred position line.
Sir?
Go ahead, beta.
सर ये जो टेरिस्ट्रियल जो पोजीशन लाइन है इसमें सिंगल एरो होता है, तो अगर अपन इसको ट्रांसफर करेंगे तो सर इसमें डबल एरो लगा देंगे क्या, मतलब इसमें टेरिस्ट्रियल में भी?
राइट बेटा, वेदर इट इज टेरेस्ट्रियल और सेलेस्टियल, अगर हम उसे ट्रांसफर करेंगे तो डबल एरो लगाएंगे.
ओके सर.
नॉर्मल पीएल में सिंगल एरो रहेगा, अगर उसे ट्रांसफर करेंगे तो हम डबल एरोज के साथ शो करेंगे.
ओके
सर मतलब both end, right sir?
It depends beta. If it is a bearing of a lighthouse, then the arrow will be only on one end, but if it is a celestial position line, the arrow will be on both the ends.
सर ट्रांसफर की बात कर रहा हूँ सर मैं.
नहीं बेटा, if you transfer a position line which is taken as a bearing of a lighthouse, आप अगर उसे ट्रांसफर करते हो तो उसमें भी बेटा एक ही एंड में एरो लगेगा ना, बिकॉज यू कैन नॉट बी ऑन अदर साइड ऑफ द लाइट हाउस.
ओके सर.
वही सर.
राइट.
तो सर उसमें से अपन डबल एरो लगा देंगे एंड पे बस, तो इट विल बी अ डिफरेंस बिटवीन दिस CMG एंड दिस ट्रांसफर्ड.
राइट, दैट्स राइट बेटा.
ओके.
Okay, let's move ahead.
Now, beta, the use of proper symbols in chart work plotting is, as I told you earlier, very, very important. If you have not shown proper symbols in your plot, the plot will be very, very confusing. It will be very difficult for the paper checker to understand what you have plotted. And the penalty imposed by him in way of cutting marks is also severe in the case. So even if you have done the question right, but the symbols are not there, you can lose almost more than 50% of the marks allotted to the question. So whenever you practice the chart work question, always remember to plot the correct symbols so that you form a habit of using these symbols whenever you plot. Now, using wrong symbols or no symbols will result in a very confusing plot and certainly losing a lot of marks. As you have seen in the symbols, whenever we draw positions, whenever we mark or plot positions or position lines on the chart, it is always recommended to state the times when those positions or position lines were applicable. So as you see here, with every position, the time is marked. With a PL also, it is recommended to mark off the time when that PL was applicable or effective. Now, let's go a little bit into what is the method or procedure to solve any chart work or terrestrial navigation question. Now, The first important thing which we have to do here is to read the question very carefully. So read the question very carefully and write down the given data on the answer sheet. You don't need to write down the positions of lights. It is also mentioned in the question, the latitude and longitude. So that is just given for identification purpose. Now, once you have noted down all the data on your answer sheet, double check that you have not made any mistake in noting down any of the item. Once you have all the necessary data for working out the problem, you can start solving it or start using your brain how to proceed ahead. Now, for finding out the solution of a chart work question, it is not like celestial navigation question where you know that a certain formula is to be used. Let us say if you are solving a long by Cron question, you know the formula, you pick up the data, apply it, and you get the answer. In chart work question, you have to find out what is the technique or method to be used in a particular question. So for that, it is very important to check what information is given, because the method which we use in chart work depends upon what all information is given to us. I will give you a simple example. Let's say they give you 3 bearings. In one question, all the 3 bearings are from a single object. If that is so, we use a different method. It is known as 3-point bearing or 3 bearing method. Now in the second case, they give you 3 bearings, but 2 of them are from a different object and the third one is from a different object. Now in this case, we will have to use a different method. So it is very important that we analyze the data carefully. What is provided, what information is provided to us. Now, once you have checked the data, then you can follow this short 1, 2, 3 method. Number 1 is understanding. So as I told you, you need to understand what data is provided. For understanding, it is very beneficial if you make a rough diagram. You can make this rough diagram on your answer sheet. It is not mandatory as far as the question solving is concerned, but this rough diagram helps you to understand how do we go ahead or what method do we use for solving a particular question. Because the data which is given to us in the question is in the text format. When you put it or convert it into a diagram format, it is very easy for the mind to understand that data. So making a rough diagram makes it very easy for us to find out what method we should be using here. So once the rough diagram is there and you know which method is to be used, so once that much clarity is obtained, you can go ahead and make your final plot on the chart. So remember, the question has to be solved in your mind first before you start solving it on the answer sheet. If you straight away try to jump on the chart, reading up the question from the question paper, trying to plot the required data on the chart straight away, you may get stuck in between and you may lose the track on which to proceed ahead. Now there are many calculations which are required when you convert the data from the text which is given in the question paper to what is required on the chart. Say for example, they could give you compass bearings of a particular object Now for plotting on the chart, you need to convert them to true bearings. So before we start the plotting, we need to do many calculations like this. So all these calculations which you are doing, now sometimes in haste, especially in the exam conditions, people do these calculations on the calculator and straight away plot them on the chart. So the examiner may get confused, how did you reach to that conclusion? So all the calculations which you are doing, they should be shown on your answer sheet. So all calculations required for solving the problems should be shown in detail on the answer sheet. That is the formula, any formula which you are using, the values of each parameter, and the answer obtained. All this should be clearly mentioned on the answer sheet. Now, merely calculating the values by the calculator and writing the answer on your answer sheet or on the chart will not be sufficient. That leaves a lot of doubt in the mind of the paper checker, and it may result in losing of marks. Now, if some of the data is calculated by using the Norris table, so we may refer to Norris table, we may refer to deviation card, we may refer to luminous range diagram. So whatever data we obtain from any of them, please mention the name of the table, or you have got this data from the luminous range diagram on your answer sheet. Now, after you complete a particular question, erase all the extra or unnecessary lines or markings which you may have drawn on the chart during plotting. So all these lines, all these markings which are not relevant to the plot, they should be removed, they should be erased to avoid confusing the examiner. Okay. So only keep the required item, the relevant items which are part of the plot. Now let's move on to the concept of position line. We will understand what is a position line, and we will understand how the information regarding a position line is provided to us in chart work questions. A position line basically is a line on our chart on which the vessel's position lies. So if we have a PL, we know that the vessel's position will lie on that position line only. There are different methods with which position lines can be obtained. So we will now see what are the different methods with which PLs can be obtained and how the information about the position lines is provided to us. Okay, now let's go into different methods with which position lines may be provided to us. Now, one of the method by which position lines can be provided to us is by way of visual bearings. So visual bearings of an object can be obtained by using different instruments. You can get the bearing of a object using a gyro compass. Now, if a gyro compass bearing is given to us, we need to apply the gyro error. Gyro error will also be given to us in the question. We need to get the true bearing of the object for plotting on the chart. Now, whenever we plot on the chart, we always plot true bearings. We never plot compass bearings. Gyro compass or standard compass bearings are never plotted on the chart. Now, if a compass bearing is given to us, then to convert it to true bearing, we need to apply the compass error. Now, compass error is a combination of deviation, which is obtained from the deviation card for a particular compass course, and variation, which may be given in the question paper, or the variation may be picked up from the chart. It is mentioned in the question paper whether you have to use a particular variation value or you have to pick up the variation from the chart. I will tell you how variation is picked up from the chart. So once you apply this compass error to the compass bearing, we get the true bearing, which we can then plot on the chart. Now, the third method which could be used to provide us a bearing is by way of a relative bearing. Now, a relative bearing is basically with reference to the ship's head. Compass bearings are given with reference to the compass north. A relative bearing is given with respect to the ship's head. So we need to apply the ship's heading to the relative bearing and get the true bearing for plotting on the chart.
Okay, beta, any doubt up to here, beta?
No, sir.
Okay, very good. So relative bearing, if it is given to us, we just have to add the ship's head to it and it will be converted to true bearing. So let's now move on to the compass error, finding the variation and the deviation. These concepts are also already known to us, but just refreshing them once so that there is no doubt which remains in the mind.
Let's now refresh the concept of compass error, which consists of variation and deviation. So we are going to first discuss about variation.
Beta, just give me 1 minute. I'll be back.
Okay, sir.
Okay, beta, let's proceed ahead.
Magnetic variation is the angle between magnetic north and true north, and it is caused by the different locations of the geographic North Pole or the true North Pole and the magnetic North Pole. So you can see in this diagram, in the green color, we have the true North Pole marked, and in the blue color, you have the magnetic North Pole marked. Now you can see they are at different locations. The true North Pole is basically the point from where the axis of the Earth pass through the Earth's surface. We know the Earth is rotating on its axis from west to east. Now this axis passes from the surface of Earth at 2 points. Now these 2 points are known as the geographic poles or the true poles. So the true North Pole is marked in green color here. The magnetic North Pole is decided by the magnetism of the Earth or the magnetic properties of the Earth. Just like every magnet has 2 poles, the red and the blue pole, similarly the Earth also has magnetic properties, and it has magnetic North Pole and magnetic South Pole. Important thing to understand or know here is that these magnetic poles are not located at the same place where our geographic poles are or the true poles are. They are at a different location. Also, the location of magnetic poles is not permanent. It keeps on shifting. So variation, what we are talking about here, is the angle at any particular position on Earth. It is the angle between the magnetic North Pole and the true North Pole. So you can see here in the diagram, this variation is shown here as an angle between these 2 poles, the magnetic North Pole and the true North Pole. Variation will differ from place to place. So as the ship changes its position, the variation also keeps on changing. You can visualize it here in the diagram. Now, as the position of the observer keeps on changing, the angle between the magnetic and geographic North Pole will also keep on changing. Variation is not dependent on ship's head or the course. As you can see, the ship's head or the course which the vessel is steering has got no role to play in the variation. It is entirely dependent upon the position of the magnetic poles and the geographic poles. Now variation is provided to us in the question paper in 2 different ways. One, they could mention you what is the variation to be used for solving the questions. Let us say, for example, they will give you a value of 5 degrees east. So this is a standard value to be used when you are plotting any of the chart work questions on the chart. It is mentioned in the notes which are given in on top of the paper. So that is one way in which variation can be provided to you. It can be simply picked up and used irrespective of where the ship is, anywhere on the chart. Now, the second way in which it could be given is they could tell you to use the variation as mentioned in the chart. Now, if it is given in this way, then we will have to find out what is the variation at a particular place and then use that variation in our chart. So the next question which comes in our mind is how to pick up the variation from the chart. So variation value is mentioned in all the compass roses. You have the compass roses at different locations on the chart. So the variation in that area is mentioned in the compass rose. Now, as I told you that these magnetic poles keeps on changing their location. So year after year, the value of variation also keeps on changing. So how to represent this change in the chart? So let's see now, how do we pick up the variation from the chart and how do we account for this change?
Before we go into the variation picking up from the compass rose, any doubt up to here, beta? Any doubt in the mind?
No, sir.
Okay, great.
Hi, welcome to this short video, an introduction to variation. So, what is variation? Well, we know that all vertical lines on the chart point to true north. But we also know the magnetic north is not at the North Pole. In fact, it's moving. The difference between them is called variation. So, how do we calculate variation? All charts have the information needed to calculate the appropriate variation for the area. From this, we can convert magnetic compass bearings to true chart bearings and vice versa. Essentially, we need to know two things. Firstly, what was the variation in a given year? And second, what was the annual change? Both these pieces of information can be found on the compass rose.
So beta, you can see on the compass rose, they give us the value of variation in a particular year. Like in this case, you can see in the year 2005, the variation at this place was 7 degree 20 minute west. And in the bracket, you see what is the annual change in variation. So every year the variation changes by 8 minutes in the easterly direction. So using this, we can calculate the variation in any particular year.
How do we interpret the compass rose data? The two pieces of information are written along the arrow. In this example, magnetic variation was 7 degrees 20 minutes west in 2005. The part written in brackets tells us what the annual change to variation is. In this case, 8 minutes east. Using this information, we can see that it is 13 years since variation was 7 degrees 20 minutes west.
Now beta, this video was made in 2018. So that is why they are taking it 13 years from 2005 to 2018. If we were calculating it for 2021, then we would be taking 16 years instead of 13.
And has an annual movement of 8 minutes east. From this, we can work out that variation has changed by 104 minutes since 2005, i.e. 8 minutes times 13 years, which equals 104 minutes. We can convert this to whole degrees and minutes by dividing by 60, as there are 60 minutes in every degree. This comes to 1 degree and 44 minutes east. As the change since 2005 is east, in other words, opposite to the westerly variation, we need to deduct 1 degree 44 minutes from the 2005 variation to find out today's value.
So is this clear up to here, beta?
Sir, in the question, the date will be given, or shall we take the date of the exam on the present date?
बेटा अगर वो ये बोलते हैं आपको दैट वेरिएशन इज टू बी कैलकुलेटेड और फाउंड फ्रॉम द कंपास रोज, तो आपने जिस भी ईयर में एग्जाम दे रहे हो उसी ईयर को कंसिडर करना है.
यस सर. और अगर सर क्वेश्चन में सर कोई डेट अगर दी हो, मतलब कि ना जैसे 1992 मतलब से कुछ करके कुछ दिया हो, सीधा उसी को मतलब कर लेंगे यूज.
बेटा चार्ट वर्क क्वेश्चंस में यूजुअली डेट नहीं दी रहती है. Date is only given in the cell nav questions. Chart work questions are without date.
Okay sir.
Okay, so yes, if it is given, अगर वो क्वेश्चन में आपको बता देते हैं that on a certain day, certain year, तो आप फिर उसी को यूज करोगे. But if nothing is given, then you use it for 2021.
Thank you sir.
Okay, अगर अगले साल दे रहे हो तो it will be 2022 obviously.
सर ये जो कंपास रोजेस रहेंगे, पोजीशन के जो नियरेस्ट कंपास रहेंगे सर वही यूज करेंगे हम.
Yes बेटा, that's right. The nearest one to your.
सर whatever the value is coming, वही उठा लेंगे सर कि will consider कुछ up and down.
I didn't understand your question बेटा, can you repeat?
सर जैसे कि दो कंपास रोज हैं, one is near, one is little far from the position, और position is lying in between. तो सर जो नियर रहेगा, जो नजदीक.
नो इंटरपोलेशन इज रिक्वायर्ड. आप जो भी नियरेस्ट कंपास रोज है उसकी वैल्यू को एज इट इज उठा सकते हो.
ठीक है सर. ओके.
ओके.
7 degrees 20 minutes minus 1 degree 44 minutes equals 5 degrees 36 minutes west.
So that's how we pick up the variation if required from the compass rose. Now, any doubt in your mind whatsoever? Okay, beta, great. So let's go back to the presentation now. So we now move on to the deviation. We will see what is it, how is it obtained, and how do we apply it. Let's see.
Now the second component of the compass error is the deviation. Let's understand what the deviation is and how can we obtain the value of deviation. Now, if we were sailing on a wooden ship, our magnetic compass would point towards the magnetic North Pole, or it will point towards the magnetic meridian. But the ships which we are sailing on are made up of steel. They are not made up of wood. Now, steel is a magnetic material. It can have magnetic properties and it has magnetism of its own. Now, this ship's magnetism disturbs our compass, which is known as deviation. So, ship's magnetism deviates the compass from the magnetic meridian, and this is called as deviation. You can see this diagram here on the right side of the screen. We have a boat here, a wooden boat, in which a metallic engine is fitted. Now this metallic engine has magnetism of its own. It is made up of mild steel, which has magnetic properties. So this magnet which you see, red and white color magnet, this represents the magnet of a compass. Because of the magnetism of the engine, our compass is deviated or disturbed from the magnetic north direction, and this disturbance is known as deviation. Another important thing which you can see in this diagram is, depending upon the heading of the ship, the location of the engine will change with respect to the compass needle. So the deviation also keeps on changing as the ship's head changes. The angle between the magnetic meridian and the compass needle is called deviation. The deviation varies in name as well as magnitude as the ship's head changes.
Is it clear, beta?
Yes, sir.
Okay. Okay.
Deviation could be easterly or westerly, depending upon what is the heading of the ship. The deviation is obtained from a deviation card. Deviation card is available to us on board a ship, and a deviation card is also provided to us during the exam. Let me show you a sample deviation card. You can see this deviation card on the screen. This is how it is provided in the exams. Now this particular card has actually 4 deviation cards in it. You can see card number 1, card number 2, card number 3, and card number 4. When you go through the notes in the question paper, the notes will tell you which particular deviation card is to be used for solving the questions. Say for example, a particular paper tells you, please use deviation card number 2. Then you can see we have highlighted the deviation card number 2. Then this is the card which is to be used for solving the questions. Now in the deviation card, you can see that the card is entered from ship's head by compass. We have to know what is the ship's head by compass. Using the value of ship's head, we can enter into the deviation card and pick up the value of deviation. The heading value ship's head by compass is usually given for courses for headings which are 10 degrees apart. You can see the value given for true north 000. After that, we have the value of deviation given for 010, 020, 030, and so on up to 360, which again is 000. Now to find any deviation value for intermediate headings, if you want to find the deviation value for any intermediate headings, we need to interpolate the values from this card. Let me explain this to you using an example. Let's try to find out the deviation for ship's head 145 using card number 2. Now you can see in the deviation card, we have the deviation value given for ship's head 140. The value of deviation is 5 degrees west. And we have the value of deviation for ship's head 150, which is 3.0 degrees west. Let's note down these two values. So you can see for compass course or ship's head by compass 140, the deviation value is 5 degrees west. And for a compass course of 150, the value of deviation is 3 degrees west. Now, if we want to find out the deviation for ship's head 145 or for compass course 145, we need to interpolate. So when we interpolate between 140 and 150, we can easily find out the deviation. The 145 value is exactly midway between these two, 140 and 150. So it is very easy. The interpolation is very easy here. The value of the deviation will also be midway between 3.0 and 5.0. So deviation for 145 comes out to be 4 degrees west.
So any doubts, beta? Okay, great. Let's proceed ahead.
Now, once you have the variation and deviation available to you, you can quickly find out the compass error. The resultant of variation and deviation is
Excuse me, sir.
called the compass error.
Go ahead, beta.
सर ये जो आपने डेविएशन कार्ड का बताया था उसमें जो हम लोग को डेविएशन फाइंड करना होगा वो हम लोग को मैग्नेटिक हेडिंग के ऊपर फाइंड करना होगा ना?
कंपास हेडिंग बेटा.
बट सर हम लोग जब ऑन बोर्ड करते हैं तो उस टाइम तो हम लोग जो डेविएशन कैलकुलेट करते हैं वो मैग्नेटिक को लेकर के कैलकुलेट करते हैं ना उसके बाद.
I didn't get you. Can you?
नहीं सर, जब हम लोग ऑन बोर्ड डेविएशन कैलकुलेट करते हैं तो हम लोग मैग्नेटिक हेडिंग के थ्रू फिर लेकर के कैलकुलेट करते हैं ना डेविएशन. उस टाइम कंपास हेडिंग के थ्रू नहीं करते ना.
Are you talking of the deviation which we calculate using ABC method?
नहीं सर, जो हम लोग ऑन बोर्ड कैलकुलेशन के लिए जैसे हम लोग को एरर कैलकुलेट करना होता है उस टाइम हम लोग जब डेविएशन कैलकुलेट करते हैं तो उस टाइम हम लोग अपना जो मैग्नेटिक हेडिंग है उसमें कन्वर्ट कर लेते हैं पहले, उसके बाद हम लोग का जो डेविएशन टेबल है उसको देखते हैं ना.
Oh, you are talking about when you take compass error, right?
यस सर, यस सर.
ओके. अब बेटा आप कंपास एरर में क्या करते हो? देखो ध्यान से. एक तो आप उस ऑब्जेक्ट की बियरिंग लेते हो, करेक्ट? आपने लेट अस से आपको डेविएशन फाइंड आउट करनी है ऑन ए पर्टिकुलर हेडिंग. आपने उस ऑब्जेक्ट की बियरिंग ली विद द कंपास. आपको कंपास बियरिंग मिल गई?
यस सर.
ओके. अब आपने उसके जो एजीमुथ को कैलकुलेट किया. यू कैलकुलेटेड द एजीमुथ ऑफ द बॉडी, ट्रू एजीमुथ, वो भी आपको मिल गया.
यस सर.
करेक्ट. ये दोनों आपको मिल गए. इन दोनों का डिफरेंस क्या होगा?
हम लोग का टोटल एरर हो जाएगा इन दोनों का डिफरेंस.
That will be the compass error, correct?
यस सर.
Now this compass error consists of two components. One is variation, another is deviation. So हम क्या करते हैं, हम उस जगह पे जो वेरिएशन होती है उसे फाइंड आउट करते हैं either from the chart or from the GPS, and we remove that variation from the compass error. Whatever remains is deviation.
ओके सर. और सर एक और डाउट था, जैसे हम लोग मेरा लास्ट शिप पे ट्रांसर्स का एक डिस्क था, ट्रांसर्स 4000. तो उसमें जो हम लोग मेड सी में जाते थे तो मेड सी में वहाँ पर जो वेरिएशन तो होता था चार्ट में वो डायरेक्टली हमें लिख देता था 3 मिनट, बस ये लिखता था, कोई ईस्ट वेस्ट कुछ नहीं डिनोट करता है वहाँ पे. बट हम लोग जैसे नॉर्थ सी में जाएंगे. यस सर, मेड सी में मैंने कितनी बार देखा वहाँ पे कोई
माइनस आता है वेस्ट अगर होता है तो
माइनस आता है ना,
माइनस आता है. अगर कुछ भी नहीं मेंशन्ड है, इट विल बी ईस्ट.
Yeah, there will be a plus minus with it, beta. Sometime instead of east and west, they may show you the values in plus and minus. So you just check or refer to the manual, like this manual. It will tell you plus stands for what and minus stands for what. Usually plus stands for easterly deviation. Sorry, easterly variation.
सर उसमें प्लस माइनस नहीं देता था, बस उसमें हमें मिनट में वैल्यू देता था। तो हम लोग जो वहाँ पे जैसे ईस्टर्ली वेरिएशन जा रहा है तो हम लोग ईस्टर्ली लेके इसको में ऐड ऑन कर देते थे। हम लोग वैसे ही कर रहे थे,
ओके, नहीं
मैनुअल पे
बेटा
भी नहीं
मुझे
दे रखा था
देना
इसके बारे
पड़ेगा,
में।
नेम ऑफ द वेरिएशन हैज टू बी गिवन।
नहीं, जैसे अगर 4.3 डिग्री ईस्ट वेरिएशन है तो हम लोग 3 मिनट दे के रखा हो एनुअली, तो
कौन
उसको
सा
हम लोग
होता है?
ईस्ट में ऐड करके फिर उसमें ऐड कर देते थे, क्योंकि दे ही नहीं रखा था। और हम लोग जब जीपीएस में लेने जाते थे उसमें बहुत ज्यादा डिफरेंस आता था।
ओके, रोहित, यू वांट टू से समथिंग बेटा?
Yes, sir. I also have a slight doubt regarding this variation thing on the charts. Sometimes we see that in a chart when the variation is going decreasing in a trend or increasing in a trend, like the variation is decreasing, and we know that in the next leg it is going to be, for example, say 1 minute. Sorry, 5 minutes. If we say as 5 minutes, it is going to be. So sometimes the variation that is given on the charts is such that the like it is given like 0.6 6 minutes or okay. So if we calculate it with respect to the number of years, so it shoots up to like 5 degrees or 6 degrees, which is not possible in that trend because the variation is continuously decreasing, and after some time on the same leg, if we see after some time, it is going to be more less. So the seniors, I have experienced, like the seniors say that sometimes the notation on that number, it is taken as a second, so they say that this is not minutes, this is seconds. So is it possible like this, because it is given on charts at different places? I've seen it like on the charts just on the southern part of Sri Lanka. Many a times the variation is decreasing in a trend while going coming from this Singapore. So on a particular compass rose it is given, and when we calculate it with respect to the number of years, so बहुत ज़्यादा आ जाती है. So then they say that it is in the seconds. If we take it in the seconds, तब वो उस स्केल में आ जाती है, उस ट्रेंड को जस्टिफाई करती है.
Means what you are saying is that you take the figure given in brackets in seconds, annual change in seconds, right?
Yes, sir.
Okay. नहीं बेटा, अब पहली चीज तो ये जो ब्रैकेट के अंदर फिगर दी रहती है, दिस इज इन मिनट्स. ओके, लेट मी शो यू ए एक्चुअल चार्ट. ओके, जस्ट गिव मी अ मिनट, आई विल शो यू. Okay, I hope you can see a chart, beta. Can you see the chart on the screen?
Yes, sir.
This is chart number 5048, Old Head of Kinsale to Tusker Rock. So let's go to a compass rose. So we have a compass rose here. This is the compass rose which we have. Right, beta? Can you see this?
Yes, sir.
So it is 7 degree 25 minute west. This was in 1994, and the change is 8 minutes east. So this is very much clear that it is 8 minutes. It is not seconds, beta. When we use the seconds, second की जो notation है, see, 8 minutes is written like this. If it was 8 seconds, तो फिर इसको हम बेटा ऐसे लिखते हैं. This is how seconds are written.
हाँ
Okay,
सर,
बेटा.
ये
So that's
ये जो आप कह रहे हैं ये तो बिल्कुल सही है. ये पेपर चार्ट्स के ऊपर तो बिल्कुल नोटेशंस एक पर्टिकुलर स्टैंडर्ड के हिसाब से ही दी गई होती है. बट
okay.
व्हाट आई एम सेइंग इज अबाउट द इलेक्ट्रॉनिक चार्ट्स.
Okay, you are talking about ECDIS. Right.
Sorry, but I'm
Now,
sorry.
beta,
That
yes, it is possible. ECDIS, yes, very much it is possible. So maker to maker, there could be a slight difference in how the values are shown. So for ECDIS, yes, you will have to refer to the user manual, or you need to get it clarified from the maker if this value is in seconds or is in minutes. But I would recommend, beta, जब हम ECDIS की बात कर रहे हैं, see we have come over paper charts now. Paper chart अब पुरानी चीज हो गई है. So when we are talking about ECDIS, let me talk to you face to face. Why are you using the electronic chart for variation? Pick it up from GPS ना straight away.
सर
No,
वो
correct.
इसलिए नहीं देते सर, इसीलिए मना करते हैं क्योंकि इन केस ऑफ वेरिफिकेशन अगर कोई सर्वेयर पूछेगा तो उस टाइम पे हम पे चार्ट होगा सो दैट वी कैन शो कि वहां पे इस चार्ट से हमने इस प्लेस पे ये डेविएशन लिया था. पर जीपीएस पे कोई रिकॉर्ड नहीं होगा कि हम डेविएशन दिखा पाएंगे. तो इसलिए मतलब कंपनी या फिर मतलब इट्स अनसेट रूल कि पेपर उस ECDIS से ले लो.
Okay, all
मतलब
right.
हम लोग भी इस बात को आर्ग्यू करते थे मतलब व्हेन वी वर फर्स्ट टाइम ऑन द शिप कि अरे भाई आ तो रहा है जीपीएस पे कि व्हाई
Yeah,
यू आर डूइंग ऑल दिस अगड़म बगड़म.
yeah. You first pick it up value for it
पर
another year, and then you apply the
नहीं,
correction.
अगर हम उनको बोल भी देंगे हमने जीपीएस से लिए तो फिर गलत थोड़ी बोल देंगे सर्वेयर उसमें या अपने
भाई
Yeah,
ये
गलत
सर
गलत
उसमें
सारी
एक
चीजें नहीं
ऑप्शन और
होती, पर बहुत सारी चीजें कंप्लायंस मात्र के लिए भी तो कर रहे होते हैं और 60% चीजें कंप्लायंस के लिए ही कर रहे हैं.
okay, all
सर
right.
उसमें एक ऑप्शन और है सर
नेसेसरी
उसमें मैग्नेटिक वेरिएशन चार्ट सर. ये भी मतलब होते हैं जहाज पे मैग्नेटिक वेरिएशन चार्ट. तो
That's
वो
right.
सब अपना रिकॉर्ड भी होता है और उससे मतलब एक्यूरेट आता है.
Yeah. Admiralty published the variation charts, and it is there usually on all the ships. It is there. Even though we have come to ECDIS, the variation chart is usually kept. So you can pick up that variation chart and you can get the value of variation from there also, beta.
Yes.
Okay. And I would say what Manish is saying is perfectly makes sense. अगर वो इसी बात पे आ जाएं कि भाई GPS की तो अब वो पोजीशन मिलेगी नहीं, why bother your head with ECDIS also? Pick up the variation chart और उसमें जो वेरिएशन दिख रही है वो यूज़ कर लो. अब कोई भी आपको बोलेगा कि भाई ये वेरिएशन कहाँ से ली है, यू शो द एडमरलिटी वेरिएशन चार्ट टू देम. अब उसमें कोई गलती ढूंढनी है तो ढूंढ लो.
हाँ ये सही है सर.
Okay. And the good part is that it gives you variation for the full world. So whichever place you are on, this is a single source जहाँ से आपको वेरिएशन मिल जाएगी. Okay.
थैंक यू सर.
ओके सर.
Okay. So चलें बेटा वापस प्रेजेंटेशन पे.
Yes,
सर
sir.
एक और डाउट थी, एक ये था सर कि जायरो का एरर हम हाई और लो लिख देते हैं तो उसका क्या लिखना चाहिए सर, हाई और लो और ईस्ट और वेस्ट?
बेटा दोनों वेज में लिखा जाता है. The more common way is in case of gyro is high and low. This is more common format which the navigators use, but it is interchangeable. So अगर high है तो उसे west भी लिखा जा सकता है और अगर low है तो उसे east भी लिखा जा सकता है. It is perfectly in order.
ओके सर, थैंक यू.
Okay. Okay. Let's go back to the presentation and so we have seen how to pick up the deviation from the deviation card, and now let's go to the concept of compass error.
Now, once you have the variation and deviation available to you, you can quickly find out the compass error. The resultant of variation and deviation is called the compass error. If both of them are of the same name, they are added up. If both of them are of different names, we subtract the smaller one from the bigger one and keep the name of the bigger one. So this is how we obtain the compass error. Now let's quickly refresh the procedure for converting compass to true and true to compass. Now, if you have a compass course given to you and you want to find out the true course, or you have a compass bearing and you want to obtain a true bearing, the method what we use is we start off with the compass course. We first apply the deviation, which is obtained from the deviation card. Now, what do I mean by apply? Deviation could either be added or subtracted. How to find out whether deviation is to be added or subtracted? Remember this idiom: deviation west, compass best; deviation east, compass least. So if deviation is westerly, compass has to be best. Best means bigger. Now, if the compass course is bigger, the magnetic course will be smaller. So obviously deviation has to be subtracted. If the deviation is east, the compass is least. Least means compass course is smaller. Now, if the compass course is smaller, that means the deviation has to be added to obtain the magnetic course. Once we apply the deviation, we obtain the magnetic course or magnetic heading. Now the second correction which we apply is the variation. So again, whether to add or subtract the variation, you remember the idiom: variation west, magnetic best; variation east, magnetic least. So variation is added or subtracted using this, and then you obtain the true course or the true bearing of an object.
So is this clear, beta? Any doubts? Okay, great.
Now let's see the conversion from true to compass. We have just now seen how to convert compass course or compass heading to true courses or true heading. Now we will see how to convert from true to compass. We follow the same procedure but in reverse. We start off with the true course or true bearing, then go backwards. So to the true course or true bearing, we first apply the variation using the same idiom: variation west, magnetic best; variation east, magnetic least. So variation is applied to the true course. That means either added or subtracted, and we obtain the magnetic course. Now to the magnetic course, we apply the deviation using the same idiom: deviation west, compass best; deviation east, compass least. Now once we apply the deviation, we get the compass course or compass heading.
So this is also clear, beta? Any doubts anywhere?
No, sir.
Okay, very good. Now I have one doubt. When we are obtaining the compass course from true course, we first apply the variation, get the magnetic course, then we have to apply the deviation. Now we just now saw the deviation card. Can you tell me deviation is given against which heading?
Compass heading.
Sir, compass heading.
Very good. So deviation
Compass
is
heading.
given against compass heading, but in this particular question, we don't know what is the compass heading. इसमें तो हमने compass heading को find out करना है. So हमें deviation कैसे मिलेगी? कुछ याद आ रहा है बेटा?
तो कंपास एरर से वेरिएशन अप्लाई करके डेविएशन।
बेटा ये तो चार्ट वर्क के सवाल होंगे ना, जिसमें ट्रू कोर्स निकाल लेंगे चार्ट से एंड दे विल आस्क अस टू फाइंड आउट व्हाट विल बी द कंपास कोर्स टू स्टीयर. सो इसमें तो एरर मिलेगी नहीं ना, कंपास एरर.
सर इसमें अप्रोक्सीमेट निकाल लेंगे मैग्नेटिक हेडिंग से.
ओके,
फिर दोबारा से इसमें जाके फिर दोबारा इटरेशन कर लेंगे.
वेरी गुड. यस, दिस इज वन ऑफ द मेथड्स व्हिच इज यूज्ड. इटरेशन हम इसे बोलते हैं. Either you can enter with magnetic course and then find the approximate deviation, apply it and then do it again. But we have a simpler method than this. Let me show you.
Now there is one issue which we are going to face here, and that issue is how to get the deviation. What is the problem in obtaining deviation here? The problem is deviation is given to us in the deviation card, and the deviation in this deviation card is mentioned against the compass course. Now when we are going from true to compass, this compass course is not known to us. We don't know what is the compass course. So what we know is the magnetic course. Now in the deviation curve or deviation card, the deviation is not given against magnetic course. So how to obtain the deviation when we do not have the compass course? So let's see it. Let's understand it using an example. Let's say we want to find out the deviation for a magnetic course of 153. Let me open up the deviation card for you. You can see the deviation card here. I have only kept deviation card number 2. So this is what we will be using for this example. Now, first of all, you see in this deviation card, the deviation is given against ship's head by compass. And you see we do not have the compass heading. What we have is the magnetic heading. So nevertheless, what we will do here is we will enter into this deviation card using compass courses close to our magnetic course. So the magnetic course what we require is 153. Let us pick up the deviation values for compass courses close to this. So close to this we have 150, and the other course which we have is 160. So let's pick up the deviation for 150 and 160 compass courses. So you can see it here, the compass course and deviation. For compass course of 150, the deviation is given as 3.0 degrees west. So compass course 150, deviation is given as 3.0 degrees west. For 160, the deviation is 1.0 degrees west. So we noted down the deviation for 150 as well as 160. Now for compass course 150, I have the deviation 3 degrees west. If I have the compass course as well as the deviation, I can calculate the magnetic course also. So using these two, the magnetic course comes to be 147. You see error west, compass best. So if the compass has to be best or greater, the magnetic course has to be smaller. It should be 147. Similarly, for a compass course of 160, deviation is 1 degree west. Deviation west, compass west. So the magnetic course in this case would be 159. So you see, we were able to calculate or get the values of magnetic courses from the data given in the deviation card. Now what we will do is, we can now interpolate for deviation between the magnetic courses. You see, the magnetic courses are 147 and 159. And we have the value of deviation for both of them. So exactly as we were interpolating the deviation for intermediate courses using ship's head by compass, similarly, we will now find out the deviation by interpolation between magnetic courses of 147 and 159. Now the deviation what we require is for magnetic course 153. So 147 and 149, the value which we require 153 exactly falls midway between these two. So the deviation for this would be exactly midway between 1 and 3, that is 2.0 degrees west. So you can interpolate and the value of deviation comes out to be 2 degrees west. So this is how we can obtain the deviation if we have the magnetic course available to us and compass course is not there.
So is this clear, beta? Any doubt in this? Okay, great. So we have done the concept of compass error, variation, deviation, how to convert true to compass, compass to true. So we have done the basics. Let me see what lies ahead now. Okay, now we come to our first video on position lines. Okay, so beta, the basics are all covered up and we are now ready to go into our first video for chart work, that is the concept position lines. So how do we obtain position lines? What are the different methods with which they can be obtained? How do we plot them on the chart? A basic video on this. So we are left with about 10 minutes or so in this session. Shall we start off with this video or you want to do it in the next session?
Sir, start कर लेते हैं हम.
Okay, great. Let's start then. We'll use these 10 minutes. Just give me a minute.
Position line is any line that passes through the observer's position. So once we know a PL on chart, that means the observer lies somewhere on that position line.
I hope you can see and hear the video loud and clear.
Yes.
Okay, great.
In chart work, we often refer to straight line PLs. However, sometimes non-straight line PL is also used. A unique straight line can be drawn on chart or any plane surface only if one of the following conditions is satisfied. A point through which to draw the position line and the direction of the position line is known, or we know the 2 points through which to draw the position line.
Okay, so all clear up to here, beta? Any doubts in any of the points?
So what is this non-straight line PL?
Okay, beta, in some of the chart work questions, they may give you a depth contour. They may tell you that on this particular time, the depth was, let us say, 50 meters. So if the depth is 50 meters, you know the vessel has to be somewhere on the 50 meters depth contour. So a depth contour is not a straight line. So even though it's not a straight line, we still call it a PL, a depth contour PL.
Okay, sir.
Okay. Any more doubt, beta? Okay, let's continue.
Let us now list down all the methods which can possibly be used in chart work to give us the PL. Bearings. These bearings could be visual or obtained by use of any electronic navigational aid like radar. PL by transit bearing. PL by opposite bearings. Sector boundaries of sector lights acting as PL. Depth contours being used as PL. And lastly, the celestial position lines.
So we are going to see all these one by one now in the coming slides.
Now let us understand all of these one by one. PL by bearing. On the chart, please remember only true courses and true bearings are to be plotted. The bearings given to us in the questions or obtained on ships may be gyro or compass. We must be proficient in converting gyro bearings to and true bearings to gyro. Likewise, compass to true and true to compass, depending on which compass, whether the standard compass or the gyro compass has been used for taking the bearings. If in doubt, please watch the video on compass error and its applications.
So this we have seen, beta, just now, how to convert compass courses to true courses or compass bearing to true bearing and true to compass. So any doubt up to here, beta, in any of the points? Okay, great. Let's continue.
Now, PL by bearing. Let's understand this through these small examples. Plot the following PLs on chart. Old head of Kinsale, light bearing 270 degrees compass, variation 5 degrees west, deviation 3 degrees east.
Now, beta, these plots which we are seeing on the screen now, they are very, very basic and very, very simple plots. So this is the first thing which is done in pre-C when we start off our chart work. But I'm still doing them. Nevertheless, we will spend 5 minutes seeing it. But it clears any doubts whatsoever in your mind. Okay, so let's watch.
And the second one, Roche's point light bearing 330 degrees gyro, gyro error 2 degrees low. First thing is we need to identify these landmarks, old head of Kinsale light and Roche's point light on the chart. You can see that this one is old head of Kinsale.
Beta, all the examples which will be there in the videos or in my slides, in the presentations, they are all picked up from chart number 5048, the chart which I just now showed you, old head of Kinsale to Tusker Rock. So 5048 chart, you can identify, you can find all these references.
Okay, sir.
This one is the Roche's point. Now we need to convert the compass and the gyro bearings into true. Now the first case, we have the variation as 5 degrees west, deviation 3 degrees east, compass error shall be the algebraic sum of variation and deviation, which in this case would be 2 degrees west. The compass bearing of old head of Kinsale is given to be 270 degrees compass, to which we apply the compass error and obtain the true bearing. We can remember the old rhyme, error west, compass best, error east, compass least, meaning if error is west, then compass is more than true, and if error is east, compass least, compass is lesser than true. So in this case, error west, compass best, and thus the true bearing of old head of Kinsale light is 268 degrees true. The second one is the Roche's point light bearing 330 degrees gyro. Gyro error given in the question is 2 degrees low. Low gyro error means that the gyro values are lesser than the true. So accordingly we apply, and true bearing of the Roche's point is then 332 degrees true. Now we plot these bearings, we use compass roses, and we plot the bearing on the side on which the vessel may be. We don't have to draw it on both sides. Now you can see on this chart, this old head of Kinsale, light bearing 268 degrees true. So the PL is drawn in the reverse direction. So if you're anywhere on this PL, which could be extended to whatever length you need, the bearing of old head of Kinsale shall be 268 degrees true. Likewise, for Roche's point, where the bearing is 332 degrees true, you draw it in the reciprocal direction. So now wherever you may be on this line, the bearing of Roche's point light would be 332 degrees true, and this line could be extended to whatever length we need for our purpose.
So any doubt in the procedure, beta, up to here? Okay, great. Okay, so we are almost done for the session. Let's keep this for tomorrow. We will do the transit bearing tomorrow, and we will do the remaining methods also.